Hi guys. So today is continuing for lead coding, and we doing the next task. So let's check. Share my screen. Let's go. So today's task is basically the classic one. So we should implement something. What does it mean? It means that we are given some integer array, and we should return all three triplets where nums I, num j, nums k, such that I is not equal to j, I is not equal to k, and j not equal to k. So such that when we sum all these elements, we are receiving 0. Yeah. And we should notice that this solution set must contain duplicate triplets. So for example, we have some numbers. Yes, when we add up all these numbers, it will give us 0. But also we have here another one, and it would be duplicates. We should not actually include this into our results, right? Okay. So what can we do actually here? Let's think. So about understanding, understanding, we have some array with some values, for example, like this, and we should our transformation. We should return another possible arrays that when we add them all, we will get 0. So at the beginning we have like another, let's say 4. So in this case we just return the results. Okay, so thinking about edge cases and constraints, I'm thinking about this array length. I expect that solution must not create duplicates, okay, and array length would list 3, and it at most, let's say 10 in the 6th power. Also, values in our array, I expect that we have negative values here, so 10, let's say in the 5th power plus 10 in the 5th power. So we have duplicate values in our array, and our array not sorted. I think that's a pretty all constraints that I need. So let's check with the constraints that we have. Okay, so we have 3, and here it's not 10, is the 6th power, would be 3 multiplied 10 on the 6th power, right? And here it's 9 to 5 plus 10 of 5. So, okay, nice. Great, so let's think about solution. So the first solution, when we have our array, what we can do, let's let's this array, for example. So we can start with the first element, right? With the first element, then we can like do the next loop, the next element, and so do the next loop and start with the next element. And in this case, we are checking. Okay, so if we construct another array, right? So we should actually what we should do, we should add into our result array new array with -1, 0, and 1, right? So we should add all these threads here. Okay, and this triplet should be added to should be added to in sorted order. So there should be set to not have same duplicates. sorted, and also we should calculate hash set over them, right? Okay, yeah. So we can have the result of our set, and then we are going through this and actually construct the next result. Yeah. Again, so that's it, right. So this solution is 3 loops, and time complexity would be O n or 3, and it's 3 over, and space complexity would be O of 1. Okay, let's think about some other solutions we can have. So the other solution, for example, we can take an element -1, right? And do the two-sum problem here. What do I mean by two-sum problem here? So by two-sum problem, I mean that two-sum problem, we have some target that would -1. I have some like 0, 1, 2, -1, and 4, right? And here, what we should do is actually go by this element and check if we can get some value with this element to construct our 3-sum. So to get this, we also need to have some map. We have value here, and also count how much appears. So we have 0 appears 1, -1 appears times, 2 appears 1 time, and 4 appears 1 time. So we have this map, and for each operation we are doing such calculations. So absolute target, or target -1, should be equal to array I plus get get target -1 and minus array. Yes. And here is actually so here we actually do some check, right? So before this one, we should do some check. So if it exists, right? So it's not equals to null, right? And also, what is important, when we get this value from our array, we could have like this, like -1, right? So we can point over ourselves. So to not point over ourselves, we should do like this. So we should like search element, and if this value is equal to target, then yep. So if it's equal to target, and this element should be greater than 1. Yeah. Okay. Mm-hmm. Yeah, so we should check this case when our value target is the same value that we should find, right? So actually what we need to find, so with -1 we should find 1, right? If, yeah, so if target 0, like 1 minus 0, it would be 1, so it not equals to target, right? But we can have like this, for example, we can have minus, right? Or we can have 2. So -1 minus 1 minus 2, it would be -1. And if it's equal to target, we should check that this value is greater than 1. So actually we should do some some double check here as well. Okay, so in this case, what we are doing, we are like mapping each element and do 2 sums for each of these values. So we have like not stick, but like one element plus 2 sum problem. In this case, time complexity will be n quadratic and space complexity will be n over n, because we need to create some map data structure here. Okay, and third solution, let's think about it. Do we have a solution? So if we will sort all our elements, would it be some benefits for us? So if we will sort them, and let's say we are taking -4. So to get -4, we have another loop with 2 pointers, and let's say we are looking for. So when we add all this, when we add 2 elements together, we are getting 1. So we get 1. We need to get her. So I need to move then my left pointer here. Then I get again left like 1. So I have to again my pointer here. Then I have 2, right? So yeah, so 2. Then I have 3. Yeah, so it's not correct. Then I move my next pointer to -1, and again I start with this thing, and I'm looking for in the -1 plus 2 would be 1. So I would put in my result this combination of -1, -1, and 2. If they if I have this combination, if I have this combination, then I can have I can move whether my pointer or right pointer, and I think it doesn't matter. So if I move my left pointer, I have 2 is greater than 1, so I should move my right pointer here, and here I see would be 1, so I also will add result minus 1, 0, and 1. Okay. Okay. And in this case, I again move my pointer, start with 0 and 2, move right pointer, and yeah, and move again this one, and here it would be my last result. So in this case, I set I'm still retrieve my result, and in this case, I have like 10 plus 2 pointers, and time complexity will still n squared, because I'm going like for each element, I'm going another one direction, but space complexity will be constant, because I don't need to allocate additional number here. So I think this solution quite promising for us. So let's try to implement it. All right, here. So what are we doing? We are doing the following. So we are reset our elements. Then we have I. Then we go by 1. Then we have set of, let's say, set. Okay. We are going 1 by 1. So here we equal our value nums length, then I plus plus, then nums would be integer current value, or let's say target, nice, and not length. So here we are going to till the end, but we should go till 1, so length minus 2. And what should we do? We also have we have this at find results, and we are adding our I here, nums, and set. And in a result, what should we do? We actually should go through all of elements in our set. So find out we go through elements set. So it would be this result. Okay. And we should turn the result. Here we turn through every set round and a list of I don't know, array to list, and yes, and we do something like this. So now we should use this find result method. What results int I, int nums, and set of this values. So our target actually is nums I multiplied by -1. Yes, and we should have it would be I1 and right it would be always sums 1x minus 1. And we do while right is flat greater than 0. Okay. And in this case, what we do? We show the following. I think here we actually also need we don't need to have here's a set our result. What it would be a list? Maybe it would be better for us. And in this case, we have this list. We don't do it like this, or do like res and yeah, do something like this. I think it would be event. Oh yeah, so we have right and left. Here we have our list. Okay, right, left. So we should take now our list. We are taking left. It will be left value and right value. So if our left value plus right value equal target, then we should add list of a list of like our value left right right value. We should set basically else if it is a target and else. So here we should basically move our left right pointers. So what it means? So for example, we have target. Yep. So we have target 1 and we have 2 or let's see like this. Yes. So we sort them -4, but -4 we don't have. So we have -1 plus 2. It would be 1. So it's less. So we should move left pointer. So if it's less, then we move left pointer. If it's more, then we move right pointer. Yes. Okay. Let's try to run it. Okay. So what is the problem here? We have files can't find symbol. Why? Why can't find symbols? We have nums. Okay, we have set. Sort. Okay. Here's the problem basically with the sort. Yes. If we run it, here we should have now problems with set. So can find symbol, can find symbol. Okay, why can find symbol? Find results. Find result. Find results. Yes, and now. Okay, we have time limit, right? Okay, but if we go like this one, do we have time limits as well? Okay, time limit. Time limit exceeded. Interesting. So why is exceeded? We have tried, and its test case not so big. So we have some, and it will probably here, somewhere here, I think. So, yes. So here we should move also some, let's say, I don't know, left pointer. Yes. So yeah, so we see that we have the output, but we don't have output right here. So probably we should also do 0. Yeah. So now we see all these test cases here, and let's try to submit this. Nice. So we see that, yeah, indeed, we have our solution with sort and 2 pointers, but we also have other solutions here as well. That is more optimal one. Okay, so here we have triplets. First, set. Okay, optimizations, noms, collection sort. It is most bitmap. Okay, bitmap. 3 some size. Do we have some editorial maybe? No solution. Okay, both 2 pointers and hash map approach. 2 pointers. Okay, so we assort them. Break. Hash map approach. Yes, actually we have like 2 approaches here. Set. So what we do with set? So we sort them, then we go -2. Yeah, left and right, and we actually do the same case. So I think that it's probably, yeah, the optimal solution here. It's, yeah, probably not the, yeah, no so good with runtime, but actually the logic is pretty straightforward. Well, thank you very much, and see you next time.